Good morning, everyone. So today I'm going to tell you about what is stereochemistry. I'm Dr. Hardeep, and I will let you know that how stereochemistry play a very important role, and it is mm, not easy that to understand, but if you will learn, if you will do it step by step. So let's go for the further. So I'll talk about that. What is the definition of how we can define the stereochemistry first? So if you will see this carbon is sent to carbon. This is called carbon. And here it is also a carbon. So what is the difference between this structure and this structure? This is a 2D drawing, not appropriate for stereochemistry. And this is a 3D dimensional structure of that compound, which is very, very appropriate for stereochemistry. We are using this word stereochemistry. What does this stereochemistry mean? Stereo, basically, we deal with the 3 dimensional structure of a compound, which also show their effect on their physical and chemical property. So this is particular branch of science which deals with 3 dimensional structure of a compound and their effect on the physical and the chemical properties. This is known as your stereochemistry. So to represent these molecules, first of all, this carbon should be sp3 hybridized. S means 1, P3 means 4. That means 4. That means your carbon should be attached to at least 4 different carbons. So this carbon, if it is attached to 4 different groups, that can be as represented by C star. You can see represent like C star, that is called chiral carbon. So if I am not wrong, I think you should understand this thing that to represent any molecule, to 3 dimensional molecule, we need at least one carbon, which should be sp3 hybridized. Okay, so in the next slide, I'll let you know that what is the historical background of the stereochemistry, how it gets started. So, firstly, in 1848, this scientist, this Louis Pasteur, who was a chemist, he was basically discovered a tartaric acid crystals that can exist in the 2 forms. If you will see here, it can be easily exist in the 2 forms. So here you can see that what is any difference between, if I'll check it, this is the mirror image of this one. The first one is the mirror image of second one. So basically it is a tartaric acid crystals that can exist in 2 different forms. And they were having mirror images of each other. So he separated all these crystals manually under a microscope, and he just demonstrated that when they just taken these crystals and they were rotating the plane polarized light in opposite direction. Means this was the first identification of optical isomers. So what are optical isomers? Basically, that first of all, you should know what are isomers. Isomers, who's having same different, same molecular formula but a different structure. They are called isomers. You will see that they all having same carbon number of carbon, number of hydrogen, number of everything, oxygen, but the structure is being different from each other. So optical isomers which rotate the plane polarized light towards left or right side, any direction. They can be D or L, dextrorotatory, or they can be levorotatory. So he just separated out these crystals and he got to know that they are rotating the plane polarized. So it was just a first identification of the optical isomers. So how it gets started? This development of the stereochemistry basically has rich history and has marked several discoveries by all these scientists. So further, in 1874, Wenthoff and Liebel, both were the different scientists, they were doing differently, independently. They have proposed 3 dimensional arrangement of atoms. They said there is a one central carbon. This is central carbon, which is a tetrahedral. Tetrahedral means sp3 hybridized. sp3 hybridized. So they just given this. Means they propose this 3 dimensional structure of the atom with around the central carbon atom, that is a tetrahedral. So this was something that is another revolutionary idea that explained that how these stereoisomers exist. and this also give us the optical activity. So all the optical isomers who rotate the plane polarized light to left or right direction, we call them, they are having optically active compound. Or even we have whatever we have given the three, two examples, that was not sufficient to introduce that the application or the introduction to the stereochemistry. The another very important aspect was given by the Emil Fischer in 1890s, who has given a very important formula that is called Fischer projection formula. In this, Emil Fischer has given that how we can represent a two-dimensional, a three-dimensional structure in the two-dimension, means it was opposite. So the before they have let us know that how we can represent that compound in a three-dimensional structure, but how this Fisher help us to present the three-dimensional structure in the two-dimension, which is widely used in everywhere. Even today itself, we will further study this Fisher projection formula, in which that this is a carbon which is attached to four different groups. Is it fine? So here he is saying that this is the carbon which is attached to four different groups. Now, when you are saying that the carbon, one is which is pointing towards the observer, another which is back, and two are on the plane. So this is something that you want to show, that these are on the plane, and this is in front of the, and this is the backward direction. So this is how we can represent all this. So we will see this in the Fisher projection when we will discuss this. Now, it's the scope of the stereochemistry, why we are studying this first of all. So if you will see in pharmaceutical, if you will see, there is one drug is there. What is thalidomide? In what basically what is thalidomide? It is very, very important to be used as a sedative to treat morning sickness. And if you will see it, it has two isomers, R and S. They are having the same molecular formula but different structures. So these two isomers having different, chemical and physical property, you can say, means if one is using as a drug and another is using not as a drug, it causes severe birth defects. So that this tragic incidents understood the importance of the stereochemistry in the drug development. So we can say that stereochemistry is playing very important role in pharmaceutical industry, and many drugs which are chiral and they have different enantiomers of drugs which can be vastly used in a human body. So thalidomide was the one example from that. The another one was the ibuprofen. So this is also painkiller. So ibuprofen was many girls take this. The painkillers, it is, but only one isomer is active in relieving the pain, not the another. So the inactive isomer does not contribute to the drug's therapeutic effects. So now we can think about that how stereochemistry is important. That the one thing is existing in two forms, S or R, cis and trans, different forms in stereochemistry. What I am talking about, I'll let you know one by one. So just today I'm letting you know why stereochemistry is very important to us in other field also, and how it gets started. So in nature, you have seen that stereochemistry is a very, very important part. Even, many biomolecules like proteins, as amino acids, sugars, they all are chiral. So they are having specific three-dimensional arrangement of the atoms, which shows their critical function. Like if I talk about the protein. So in protein, protein is made up of chiral amino acids. So their specific arrangements of these men determine the protein structure and the function. Okay. Similarly, in the DNA, this DNA is double helical structure like this. Okay. It is having a double helical structure. So it is all this double helical structure and the base pair which are there, and these amino acid adenine, thymine, guanine. So So all they are having because of the specific stereochemistry they are following in the three dimension. Now, if I'll talk about the material science, the stereochemistry also play a very important role. Like, for example, the properties of the polymers can significantly affected by the stereochemistry because the monomers, how they are arranged themselves. If I just want to take an example, the arrangement, if the carbon is arranged in a well manner, then it is diamond. If it is not, then it is normal carbon. Okay, it can be a crystalline nature, it can be amorphous nature according to the stereochemistry. So in agriculture, if I'll say stereochemistry of pesticide and herbicides, very, very important to me. Like some stereoisomers may more effective or less toxic than others. So that's why it is very, very important to understand the stereochemistry of every compound which is being used in the agriculture and which stereochemistry. I hope you understood this thing that how we can, start the concept of stereochemistry. So, in conclusion, I would say that stereochemistry is just a part of just a part of our life that you should understand that if your stereochemistry is to represent any compound in a three-dimensional manner, three-dimensional structure of a compound. Okay, because its three-dimensional structure affects its physical and chemical property and their effects, which is being used. In our next video, we will talk about the terminologies are being used in stereochemistry and whatever I have used like optical activity, enantiomers, isomers, like all whatever I have used in the previous lecture, I'll continue with the another lecture. So I hope guys you understand what is the stereochemistry, why it is very important, and how it gets started with the some concepts and some discoveries. So thank you guys. So in the next video, just stay tuned to my next video so that I can let you know what is stereochemistry and what type of the terminologies are being used in the stereochemistry. Thank you.